if x is greater than 2, this, for instance, if x is greater than 2, console.log x else console.log x is less than 2. Let's execute this code and see what happens. Sorry. X is less than 2 because x is equal to 2. It's no greater than 2. But the problem here is x is a global variable because it can be accessed before this scope and after the scope. You can access x inside this scope and outside of this scope. Let's say this is a function. You can still access x here. As you can see, you have x is less than 2, and we still have a value of x, which is 2. So in this case, x is a global variable because it is defined outside of this functional scope. But if only we want to access x inside of this scope, we can do something like, we can define a function, let's say add, and we want to access x only inside of this function. You can just say let x equal to 2, and if x is less than 2, you can just console log x else we log x is less than, sorry, x is greater than 2 on the console. In this case, you cannot access x outside of the functional scope. This is a functional scope. It's a local scope, not a global scope anymore, because x is defined, is declared inside of the function and initialized to 2 inside of the function, not outside. So you cannot access x outside of the functional scope. Now, if you try to log the x in the console outside of the functional scope, you get an error. X is not defined. Reference error, x is not defined. As you can see, console.log x is not defined because x is a functional, it's in the function, not outside the function. That is, it's not a global scope, it's a local scope, so you cannot access it out of that function. So that is, we'll be talking about scopes in depth, but for now, let's limit it to here. And let's talk about the lexical scope. In the lexical scope, I will try to show you an example how lexical scopes are being created and what it's all about. A lexical scope, it's an environment of a function, the outer environment of an inner function. Let's say we have a function of add, and this function returns another function of, let's say it returns an anonymous function. So the lexical scope of this inner function, the lexical scope of this very function here, is the functional scope of the outer function. Let's say this is the lexical scope, the beginning and the ending of the lexical scope of the inner function. And the beginning of the lexical scope of the inner function is the beginning of the functional scope of the outer function. This function, its functional scope is from here to here, and the inner function, its lexical scope is from here to here. And the inner function can be able to access any variable that is defined outside of its local scope. This is a functional local scope. In this case, this functional local scope is inside of the function, not outside, but its lexical scope is outside of its environment, but not outside of the outer function, inside of the outer function. is the lexical scope of the inner function. So any variable defined outside of this inner function can be accessed inside the inner function. And this is where closures come in. Even after this function is invoked, you can still recall its environment outside of the local scope. Let's say we have something like let m equal to 4. And we come down here, we say log m to the console. Now, after calling this function, result is equal to add. And what's happening here now is add will return the inner function and pass it to result. Now, what result is holding is this. Simply result is holding, let's say result is equal to console.log m. Because after this function, it will not execute, but it will return its execution context to the outer function. Now, if you want to see the value of m as logged on the console in the inner function, what we simply do is we'll call this function. And we can see the value of 4. Why is this possible? This is possible with the use of closures. Prior to ES6, this function wouldn't have been possible. Why? Because without returning this function, you cannot access the function outside of the add function. You can simply do something like, let's say, let's give it a name, log, then we call the log in the outer function. Then we try to execute the add function. Now, if you execute the add function, you get a value of 4. But immediately you get the value of 4, the inner function disappears. You cannot be able to access the inner function again. But when you return it as an anonymous function, you can be able to access it, even without calling it in the outer function. So that is the importance of the lexical scope and in closures. You can be able to access the outer variable of an inner function and use it in that inner function, even after executing the inner function. The variable will still be alive in the inner function will be able to record that variable that's outside of the inner function, which is also inside the outer function. Now, this takes us to closure scope chain. Now, we'll be looking at some importance and applications of closures. But first of all, we have to understand the scope, the lexical scope, the closure scope chain, and all of that. So actually, we have the local scope, the inclusive scope, which may be a block scope, a functional scope, or a module, or a global scope. So talking about local scope, I will use an example to like showcase all these. Let's say we have a function add. Let's m equal to 10. Then we have a function add 1 that takes in a parameter of m. It returns another function add 2 that takes in a parameter of n. This function also returns another function add 3 that takes in a parameter of o. And this inner function simply adds, it simply returns m plus n plus o plus z. Let's say the global variable is z. So it simply returns the sum the sum of M, N, O, and Z. So in this case, the local scope here is the environment of the inner function. This is the local scope. And the functional scope are the local scope is the environment of the inner function. That is a functional scope. Then the enclosing scope, in this case, the enclosing scope in this case is a outer function. This is the enclosing or functional scope. And then outside the outer function is the global scope. So understanding all this is very important in closures, so as not to mess things up. So in the global scope, you can access any variable that is defined in the global scope. You can also access 10 here. You can log 10 on the console, the Zs, and you'll be able to access 10. But you cannot access N, M, or O outside of this function. To be able to do that, you have to execute, you have to see const add 2 is equal to add 1. You pass in, let's say we pass in 2 as the argument to the parameter, and const add 3 is equal to add 2. We pass in 3 as an argument to the end parameter. Then we call add 4 is equal to add 3. And we pass in 4 as an argument. Now we log this function, add 4, sorry, add 4 to the console. Now we get 19, because 2 plus 3 is 5, 5 plus 4 is 9, and then 9 plus 10, which is a global variable, is 19. And you can also do this with, using anonymous functions without giving these names. You can eliminate the names here. And what you can easily do is log this to the console directly by calling add 1, then you pass in 2. Add 1 will return the inner anonymous function, which has a parameter of n, then you pass in 3. This function will return the innermost function with a parameter of O, then you give it you pass it an argument of 4. And if you log this to the console, you get 19, because this will return the inner function. The inner function returns 10 and add it to 4. We have passed an argument of 4 for O. So 10 plus 4 will return 14. 14, it will return 14 and add it to the outer function with a parameter of n. We pass it an argument of 3, making 17. Then 17 will be returned and passed to the outer function with an addition of 2, making 19. In this case, the simple logic here is const add 1. If you pass in an argument of 2, here, this is equal to, let's assign it a variable of result is equal to add 1 with an argument of 2. So as you can see, when we close these brackets, what you are seeing here, it's returning about 1, 2 functions. So this function returns this and this one returns this. So if you pass it an argument of 2, it will return the inner function. If you call this inner function and pass it another argument, it will return this function. As you can see here, if you call this one and pass it another argument, it will return the innermost function. And the innermost function will execute and pass the execution context to the outer function, and the outer function will print the result to the screen. I think that's all we'll have to say about the scopes, the global scope, the inclusive scope, which can be functional, a module scope, or a local scope. Let's take, for instance, a module scope here. Let's say we have a function that returns a number, get number. Let's make it an anonymous function, an arrow function that returns 3. Returns 3, and we have another function that sets a number, sets number. It takes in a number parameter and sets the number. Let's make it a global variable here. Let x equal to 20. Then this will return x. This will take in a number and then set the value of x to the number. X is equal to a number. And we want to use these functions in another file. So we simply export these functions. We export get num and set. Then we'll create another file. Let's name it test.js. Then we'll simply import get num and set num. And from here, we can be able to use these functions in this file. You can simply say log get num. Where are we in? Let's make it closure.js for module resolution purposes. So now we want to log this number to the console, and the number here is x. So get number will simply return x and log it to the console. So if you execute node test.js, or we cannot import statement outside of a module. So what we're going to do here is npm init-y. And it will generate a package of JSON for us. Then we'll come here and we'll say type is module. And then we clear our terminal and then we run it again. I will see the value of 20. Now, when creating products for other developers or writing code for other developers, you don't want to expose your implementation details. You want to expose some interfaces for them to use, but not all of your implementation details. Now, simply, they don't know the kind of logic that is going on in here. But you've simply exposed the get num and the set num function for them to use. So here, a user can simply call get num, or let's say, can simply call set num and pass in a value of 34. Now, if you want to see the value of the number now, you can simply run this file and you get the value of 34, because you don't know the implementation details, but due to documentation or some other means, you've got to discover that if you want to use these functions, you can simply set your number and get your number easily without knowing the implementation details. You don't even need to know what's going on here. You can simply say, okay, if number is less than 18, you will log number is less than 18. Else, you simply assign the value of the number to x, which is equal to num. We're simply taking it as a parameter and we are assigning it to the value of x. Now x will become this number, but not 20 anymore. So if you come here now, and let's say we're assigning the value of 15, to X now. If you try to run this file, we get number is less than 18. As simple as it is. Now, this will still log 20 because the value of number is not assigned to X because the number is less than 18, and our logic here simply says if the number is less than 18, we should not assign it to X, but we should simply log to the console that number is less than 18. And the user using this don't know the implementation details. All he needs to do is you can simply give him a comment or write some kind of documentation, but your number must be greater than 18. So that when you try to assign any number less than 18, they will simply get a text on their console indicating that no, the number you're trying to assign is 18. So this is just the uses of closures in modules to expose some functionalities to the users, but not all of your implementation details and all of that. So understanding the scope, the lexical scope, the closure scope chain, and the block scope, functional scope, or module, we'll jump into importance and uses of closures. Now, closures can be used to protect data, to construct functional factories, to write callback functions, to handle events in web applications, and it can also be used in memorizing expensive calculations or expensive functions. Now, we'll first of all start with data privacy. Using closure, now let's say you want to build a function that takes in a number and increase the number by 10, but you only want to give them an interface that they will be able to pass an argument, and that argument will be added to 10, and the result will be returned to them. But you don't want them to know what exactly is going on inside of that very function they are using. Now let's write this function. Let's give it a function of add 10, a name of add 10, sorry. Now inside this name of add 10, we return an inner, let's say let's give it a private variable. Let number equal to 10. Now we are trying to create a lexical scope here. The inner function will be able to access this number here because this is its lexical scope. The outer function can as well access it, and the inner function will as well access it due to the use of closures. Now we define another private variable, or let's call this a method, a private method that will simply increment this number. We simply increment whatsoever the person is, the user is passing in here as an argument. Let's give it as, let's pass it a parameter of num. Then this will return a function, an anonymous function that simply add this number plus sorry. Let's initialize the number to 0 for development policies and best practices. Now we don't need to leave that number to be null. We should just initialize it to 0 so that even if the user doesn't pass in any argument, we can still add 10 to 0 and return 10 as a result. Then what this function is simply doing here is The inner function is simply adding the variable num passed in by the user. The user will pass in an argument. We are just referencing this parameter for the argument that the user will pass in. So now this parameter will be added to 10 and the result will be returned. Now let's write methods that we want to expose to this user that the user can use to manipulate this add function. Now let's return a couple of functions. Let's say increment. What this increment function will simply do is it will return the number added to 10. Or if it will simply return add, the add function. Just return the add function. And then we can also write another method here, which is a value to get the value of the number. And this here will simply return the value of 10. It will return number. Now we can call our function, we can call const result now is equal to add 10. And the 10 is demanding for the value to this parameter. And let's pass in 2. Then we can simply say log result dot value. And value is a function, so we'll call it. Then we'll log it to the console. Oops, Kabli. It's throwing an error that module can't find module test. Oh, sorry. Executed test.js instead of closure.js. I will get the value of 10. Now, we can simply return, let's call this method result.increment and see what will happen. It's returning undefined. Result dot add. Sorry, it's a mistake here. Increment here will simply return number plus 10. Every time you call increment will add 10 to the number parameter. Now let's call increment let's call result. Go to add 10, then pass in a number of 3, an argument of 3. Then let's say result dot increment. Let's call it the first time, then log it to the console. Result dot value to see the value of the number now. We're seeing 10. But the number we're passing 3. And we're supposed to add 10 to 3. So why is it not working? We're returning increment.
We put none instead of number.
Yeah, you said?
We put none. Inside the increment method, we put none plus equal to 10 instead of number.
Okay, yeah, that's true. Okay, num is equal to, sorry. Let me review this function. Num is equal to 0. Okay. Number is 10, and increment, we simply increment the number. We say number plus plus, and we call it, and we're getting 11. Number plus equal to 2. We're getting 12, yes. So number plus equal to num. And we get our required result, which is 13. We're passing an argument of 3 here, and we're adding the 3 to the initial number, which is 10. So if you add 3 to 10, we'll get the result of 13. So you can pass any value you wish to pass. You can pass 30 and execute this function, and you get 40. 30 plus 10 will give you 40. So actually, you don't know the user will not know the implementation details of our function. The only thing you can equally export this function as let's add equal to add 10. Call it add 10, pass it 0. Then you can equally export add. Now, when you export add, the person will be able to use, the user that is using your product will be able to use this add function. Then the person will, the user will add it, will call the function, will be able to use your add function without knowing the implementation details. This is a kind of data privacy, and you can even implement some kind of logic in here. You can say if num is less than 26, if it's less than 26, this should simply multiply the number by 2. Number is equal to number times 2. Now, the user doesn't know what's going on here. But if the user calls this and passes in the value of 10, and then tries to call add.increment, then log the value to the console, add.value. The user is getting 30 because the value here is less than 26, and the number here, the number 10, is multiplied by 2, returning 20, and 20 plus 10 will then give you 30. But simply because of data privacy, you don't want the implementation details to be exposed to the user. He or she can only see the methods that are being exposed. Now, if you want to know the method being exposed from this function, you can simply call the add function, try to access the method, and you see, you see increments and value. These are the only method you can use to access this function. Now, if you try to add that number, if you're trying to console the number, like you are trying to access the number, you get an error because this is a private method and not a public method. It's inside of the function. And this is the use of, this helps, closures helps in closing implementation details that the user cannot be able to access. You don't want anyone to mess with your code. You only want them to access the functions available to them, the ones you've exposed to them. So if you try to run this file, you get an error, undefined. Number is undefined because it's not a global variable. It's a local variable inside of the actual function. So you cannot access it outside, except you try to like define the number outside equal to 10. Then this will be a different case. Now you can access number here, but not add dot number. You can only access number because the add dot number is returning the number from inside the function, not the one outside the function. So for data privacy, that's it. And you can also write a complex function that you want. Let's say you want to write it to uppercase function that takes in a name, then returns an inner function that simply, this inner function simply converts this name to uppercase, n dot to uppercase. It returns this name, convert it and return it. Sorry, return name dot uppercase. Now, if you try to access this function and pass it a name, let result equal to uppercase, then you pass in, let's say I pass in Chris. Then I will try to access result. Result is a function that will log it to the console, then execute the file. Now you can see Chris is in uppercase. Let me clear my terminal and run it again. This name, it's capitalized now. It's in uppercase, not in lowercase. This is a use of closures. The user doesn't know the implementation details, but he can only call this function and do whatever he wishes to do with it. You can even, the user can even go ahead, he wants to log a name to the console like hi, or the user may write another function that logs a name to the console like, let's give it CL name log hi name. Now you call this function CL and pass it Julie, then execute it. Hi Julie, but Julie, okay, let's change the first letter to a lowercase character. Then you execute it. You see hi Julie, but Julie, it's in lowercase and the user wants it to be in uppercase form. You can simply call hi to uppercase Julie. Sorry, to uppercase name and execute this function. Oh, sorry, it's a function. Function here. It's returning a function and oh. And it's working. So you call in the function, pass it the name, and it will simply call this function and execute the inner function, converting the name to uppercase. Then you log it to the console. You pass in the value of Julie here, and this function will simply convert Julie to uppercase. So the user is simply using the exposed methods, but not the implementation details. It can be complex logic going on here, but the user don't need to know anything about it. You simply call the exposed methods and then make use of the methods to log, to perform some kind of operations or log things to the console or do whatsoever the program is meant to do. Let's move to the next one, the function factories. Closures are also important in function factories in the sense that you can use a single function to construct as many factories as you can. A function factories is simply a function where you declare a function, pass into some parameters that will perform some work for you. Then you later call that function, passing arguments to reference those parameters, and then use it to construct as many objects as you can. Without speaking too much English, let's dive into an example where you want to, let's create a function greet. Greet that takes in a greeting as a parameter, then returns an inner function that takes in a name. Then it simply log the name to the console with the greeting. Greeting and the name. Now, what you want to do here is you want to simply call, let's say hi is equal to greeting. It's equal to greet. Then you pass in hi. Then you call another one. You create another factory. There's a function factory. You create another instance of that function that say hello. It's equal to greet. Hello. Now, the first one, you want the first person to be greeted as hi, followed by the person's name. You simply call it say hi. Then you pass in, let's say, Juliana. Then you call the second one, say hello. Then you pass in iKeys. Now, when you run this function, you're going to get hi Juliana and hello iKeys. With just a single function, you are able to perform two different tasks. That is a function factory. Now you can implement complex logic in here that can later be, this function can later be used to like do any kind of a task without any complexities. You can simply say this name should be to uppercase, should be converted to an uppercase name. Then you run this function and all the names will be converted to uppercase. Or you simply say you want to merge the name with another text. Let's say you want to like say, let's welcome text equal to you are welcome to KodeCamp. Then you can simply concatenate this name with this greeting and the name to uppercase. You can say hi Juliana. Then you can give it a comma and say welcome text. Now, if you execute this function, what you are getting is hi Juliana, you're welcome to KodeCamp. Hi, hello iKeys, you're welcome to KodeCamp. The only thing you need to do here is call the function, passing the argument you want to pass in, and the rest of the work will be done for you. So that's simply using our function factories to create instances. So this function here is an instance of the greet, and the stay hi here is an instance of the inner anonymous function. So what this simply is doing is, let's take a simple example of, you know how functions work. Let's say add that takes in a parameter of n, returns another function that takes in a parameter of n. This function simply adds return m plus n. So in this case, let's try to see how this works under the hood. What the inner function is simply doing is it's returning its execution context to the outer function. So if you call the outer function, if you give it a name of const result, this result is referring to the inner function, because this inner function will return, it will not execute. In closures, the function doesn't execute, it returns to the outer function. Then the outer function will execute it and pass its result to the execution context. So const result now is equal to add. Then you pass it a value of, let's say 10. Now add is returning the inner function. What add? The result now will become, the result is equal to 10, because the outer function is taking in m as a parameter and we're passing in an argument of 10. Then what will happen here is it will become 10 plus the inner function, which is function n, which adds n, which adds 10 plus n, because the outer function has executed, and if it's execute, the inner function is simply returning. We're doing it in reverse order. If you don't want to do it in reverse order, you simply get a function, the outer function, which is add. You are passing it 10. Then this function simply returns this inner function that is adding 10 to whatsoever you pass in as an argument to the function. So it will return 10 plus n. For now, we've not passed in anything. So result will now become this function, because the outer function returns the inner function. This inner function, what is simply returning is what it will execute. It will return it and pass it out to this function. So now when you call result and pass it a value of, let's say 5, now what will happen here is result will simply add, it has already returned 10 plus, and the n here, we've passed in a value of 5, then it will add 10 to 5, which will give you 15. And if you execute this function now, let's say we simply want to log it to the console. Now, if you execute the function, you will get a value of 15, because the inner function is not immediately executed. It's returned to the outer function. So the outer function will pass in its argument to the inner function, then execute it, then return the execution context back to the outer function, of which will be executed, and the result will be returned. So in understanding closures, you need to pay attention to all these things, the global scope, the functional scope. And let's talk about the global scope and the functional scope here also, so as to clarify things. Here is the global scope, in the sense that any variable declared here is accessible in the whole of this file. Any variable you declare outside of this function is accessible in the whole of this file. But any variable defined here, which is the functional scope, is only accessible in this function and in the inner function. Take note, any variable defined here is only accessible in this outer function and in the inner function. The inner function can access it because of closures. When executed, it will remember the variable defined outside of it because of a closure is formed when a function is called. Immediately you execute a function, the closure is formed. In here is a local scope. Any variable declared inside of this function, this inner function, can only be accessible in the function. You cannot access it outside of this function. Let's say, for instance, you declare let m equal to 2, and you try to access m outside, or let's say z, because m is a parameter here. So let's say z, and you try to access it outside. Now, if you run this code, you get an error. Z reference error. Z is not defined, because Z is no reference to anything outside of this function. Z is equally undefined, because it's defined it's declared in the inner function and assigned to the value of 2, but cannot be accessed in the outer function. So in this case, Z is undefined. Any local variable can only be accessed in the function in which it is declared in. And a functional scope, any variable defined in a functional scope can be accessed in this function and can also be accessed in the inner function. Then in the global scope, any variable defined in a global scope can be accessed in the outer function, in the inner function, and the whole workspace. Let me call it a workspace because any file is a workspace. That any variable defined in the global scope can be accessed in the whole workspace. So if you want to hide your variables, you know where to operate with them, you know where to access them. That's where scopes come in. You know where to access them, you know what to do with them, you know where to operate with them. So you know where to place your variables so that they will not be accessible outside of that context. And let's move forward to callback functions. Let's say you actually want to pass in a callback that a user will use to in performing different functions. Let's say you define a function that takes in a callback and converts a name to uppercase. Let's say let's just give it uppercase as a name. Then it will take in data and it take in a callback. Then inside of this function, what you simply want to do is call this function set timeout. Set timeout, which we take. Set timeout is a higher order function that takes in another function and the time it will be executed. Then inside of this function, you want to call this callback and then pass in the data, then convert it to uppercase. The data, in this case, the data is actually a string because it's only a string that can be converted to uppercase. Now you come down here, you call your uppercase function. Uppercase. Now this function requires two arguments, the data and the callback. Now you equally write a callback here. Let's say resolve uppercase that we take in a name. Let's see, Samson. Then we take in a function that will convert that name. Or you simply log sorry. Resolve uppercase. And this uppercase is taken in Samson and a function. That simply logs data, that simply logs data to the console. Uppercase is not defined. Resolve uppercase. Oops. Sorry. Function resolve uppercase, and it's taking. Let's make it an anonymous function that logs data to the console. Resolve uppercase. And we're getting a kablooey here. Type error, callback is not a function. Simply, we need a function that will resolve this something that will convert it to uppercase. And in our, let's follow up this function. In our first function here, we pass in the data and a callback. And in the uppercase, we are going to be passing in a callback as well. Let's directly pass in the callback. And let's help. It's now working. I was trying to construct the callback outside of this function so we can pass it in directly, but then we're getting an error, but it's also the same thing here. So what this function simply does is this uppercase function takes in data and takes in a callback function, then passes this callback function inside of this set timeout, which is this is 2 milliseconds. Let's make it 2 seconds, 2000. Then passes it to this set timeout higher order function, then returns the data name to uppercase. In this case, the name here, logic in here that says you want to check if the data is a number. If the data is a number, and if it is, what you want to do is you want to execute the callback with the data inside and then convert it to a string, not to uppercase, but else if it is not a number, then you want to apply the callback function, then convert this data to uppercase. Now, in this case, if we pass in 5 is a number, what will happen here is this is a string. The 5 you are seeing here is a string because let's say or let's say if the type of this is a string, if you convert it, then log number is now a string. So if you execute this function now, what you will get is you get your 5. The reason why it's taking time is because of the time. If you add this, if you increase this to 3 seconds, you take 3 seconds before execution. This set timeout. If you invoke this function now, you wait for 3 seconds before execution time because we specified 3 seconds here. That's the reason why it's taking time. Now set time out. It will first of all wait for 3 seconds, then it is begin its execution. If the type of data is number, call back the data and convert it to a string, then console the log, number is now a string. Else, if it's not a number, what you simply do is call back the data inside the callback, convert it to uppercase. Now we call our function uppercase here, then we pass in the data and then we pass in the callback function, which logs the data to the console after after performing all those instructions. You can simply log it to the console or do whatsoever you want to do with it in this function. You can call the callback. You can simply say log data times 2. Let's execute maths with strings here. After 3 seconds, we get 10. Number is now a string because we're returning 5. But in JavaScript, you know how conversion works. It automatically converts strings When multiplied by 2, it will convert the string back to a number, multiply it by 2, then convert it back to string. So here, when we got 5, it converted it to a number, multiplied it by 2, then converted it back to a string, then printed it to the console. Now, number is now a string. Because we're multiplying data by 2, and the data we're having here is 5. And let's try this out with a name. Let's say Sam. Change this 1 second, a simple function to make you understand how callback functions work with closures. Now, you can pass in a complex callback function that we perform some kind of operations. Then you expose some methods to the user to be able to use those methods to perform the functions they want to perform without knowing the implementation details of that very function. So closures are very, very useful in this aspect, where you want to expose some specific method, like let's consider Express. Yes, I just want to give you an example. When you import Express, you don't know what kind of logic, implementation details or logic that is written in that library. All you need to do is import Express, then you say something like const app or anything is equal to Express, something like that. Then you use express.app.use to use your middleware, app.do this and all your middlewares. You don't know what's going on behind the scene. All you know is the documentation you read in order to use Express told you to do so, and you are doing so, and it's working, because the user don't want you to know the implementation details, because beyond your knowledge or be able to, if you are not building product, it lacks namespaces. So closures makes it possible to bring back the lack of namespaces, where you don't want to pollute your working environment. You want all your variables to be secured, not to be accessed outside of their context. That's how closures are useful in JavaScript. Not to pollute your working environment, to hide your variables and all of that. So in event handlers, I know this is a NodeJs course, but then event handlers have to do with HTML documents and all of that. And we'll take a look at this very simple example just to showcase how closures work with event handlers and how you can use it to hide your data and just export a simple method for others to call and use in your code. Or you just expose a simple method where you by yourself, you can easily get access to it and then use in your code without having to worry about your implementation details. Let's say you want to, let me create a simple HTML file, index.html. Then we create a simple skeleton here. Then we'll give it a div of, give it an ID of count. Then we'll give it a button of ID increment. Yes, increment. Then we can simply write a script up here. But the problem is, if you write this script, before the document will render, the script will execute. So what we want to do is either we'll add a defer keyword here, or if we don't want to do it like this, doing it like this is safe. And this the normal way of doing it. You add a default word to your script so that before the script you execute, the document must have already rendered. But if you don't want to do it like this, you move your script to the body at the end. Before the closing tag of the body, you move your script there, but here you remove this keyword. Then you begin writing your logic. Now you want to define a function that that when this button is clicked, let's say increment, the button name is increment. Now let's start our live server. And yes, increment, but nothing is on the screen. Now let's come back and give this div a value of 0 and save it and go back to this. Yeah, we are now seeing 0, but when you click this button, nothing happens. Now let's implement the logic. What's going on here? You want to write a closure function that encapsulates the implementation details and expose some specific methods to be used to increment this counter. So let's jump into implementing this function. Increment, it's a function that returns another function. This inner function is an anonymous function. So what do you want this function to do? Let's say you have a private variable here. This variable is a private variable because it's in the lexical scope of the inner function and in the functional scope of the outer function. So let's say let count equal to, let's make it 2. Now inside the inner function, what you simply want to do is increment the count plus plus. But then you want a user that when a user clicks this increment button, this counter should increase. Then you come down here, then you say const inc is equal to increment. Or if you don't want to do it this way, you can simply say document dot add event listener. Now you want to add an event listener to this handler. This increment here is a button and it's a handler, but you want to add an event listener to it. Or let's say you say const inc is equal to this HTML thing is becoming somehow. Now document.add events listener, click. When you open your string literals, yeah, let's make it a string literal like this, or just normal this. Then you give it a click. Then you call your increment. Then you remove it from here. Then what you want to do is const equals document.add events listener, click to the increment handler. Then in here, what you want to do is document.get elements by ID of count dot inner HTML is equal to count. And here also we say document dot get elements by ID of increment, then add the event listener to it. Then when you click it, this counter should be able to increase from 0 to 2. So let's test it out and see if it's working. When you click, oops, it's not working. Let's check our console and let's see the error we're getting. It's actually not working. So let's review our code. What exactly is happening here? count equal to 2.
Hello. Hello, Mr. Ike. Please, can you hear me?
Okay. But the main takeaway here is this couch variable, it's a private variable in the memoize function. And the actual function performing this calculation is the factorial function. You understand? So it will access this couch. It's the lexical scope starts from here. And actually ends here.
Christopher, can you hear me?
Yeah, I can hear you.
Okay, I think you need to share your screen.
Yeah, I can hear you. You said I need to. Can you hear me?
You need to share your screen.
Okay.
We can't see your screen.
Oh. Can you see right now?
Yeah. Yes.
Okay, that's great. Sorry about that.
No problem.
The lexical scope starts from here, then ends here. Then the functional scope of the outer function starts from here, also where the lexical scope of the inner function starts and ends here also. But the functional scope of the inner function starts here. And ends here. And ends here. The difference between the lexical scope and the functional scope is a function inside of another function can access variables outside of it, that is, can access variables that are defined inside of the outer function, and that is its lexical scope. But in the case of a functional scope, it can also be referred to as a local scope, where the variables inside can only be accessed by that function in which they are being declared in. So closures makes all these things easier, and let's try to experiment this. Okay, let's say we don't return this function, then we try to call the function here, the factorial function here, and then we pass in a value of 4. Then we execute it. Then we're getting an error. Getting an error, please. Result is not a function. No longer returning an inner function. This function will execute inside of the outer function, and before the outer function will execute, it will execute and pass it. It's not returning anything. It will return this result, and then the result will just die inside of the function before returning it to the outer function. So what you'll be getting is undefined. Nothing is undefined. Everything is undefined because we're not getting any results from the function. But when you return it, you are simply returning the execution context of this function to the outer function so that you can make use of it. Then you don't need to call this function here. You simply need to assign a variable to the outer function. In this case, this variable is referring to the inner function, which is the factorial function. This result here is referring to this factorial function. But because the name is inside, this name is used as a reference. So when you reference this result to this memoize will return this function and pass it to this result. Now you can easily call this result as a factorial function and pass in any value you wish. You can pass in 5, and then you log it to the console, and then you get your result. 120. And we have our cache calculations, and you are getting infinity because this system, maybe the value of digits it can display, let's say a millions or a billions or something like that. So we've exceeded the number of digits it can display. So it's showing you infinity here. Let's reduce it to like 200 or so. Infinity, like 100 or 50. And we're getting 3.0 to power of 64. That is 3.040 times 10 to power of 64 in exponential form. It's just giving you this value here. So in essence, closures help us to achieve many things. It helps us to hide our data, create function factories, create callback functions, implement event handlers, and memorize our functions without exposing our implementation details. So if there's anything you don't understand or you want me to explain or you are confused about, you can point it out so we can go ahead and explain. Beginning from closures, the explanation, the scope, the lexical scope, the closure scope chain, and then, okay, Saad, Said, you can go ahead, you can go ahead.
Okay, thank you, sir. Sir, I just wanted to know that we couldn't hear you since when you started explaining the handler, when we want to try to use closure to increment the value when clicking on the button. We couldn't hear you. So that's why we send a message to the channel. I will advise you maybe when next we'll be having our class, maybe you should be confirming from us every 30 minutes if we can hear you or not.
Okay. Sorry about that. So we should go over the event handlers again.
Yes, you can just brief us on it.
Okay, I still have
Thank you,
the
sir.
code here. Yeah, you're welcome. This is, don't mind the HTML code. What you are focused on is this, the script, the JavaScript code here. Let's place this inside of our body. Sorry, inside of our body. And this is a closure in the sense that this number here is a functional variable. It cannot be accessed outside of this function. You can remove this number here and place it here. Let num equal to 0. And you can access it down here, but you cannot pass in an argument to reference that number. You can only call the function and then try to access it inside your event handlers. Now, after writing this function, you want to return the inner function. So when you return the inner function and pass it to the increment function, then you reference the inner function with, the inner function is an anonymous function. So you have to reference it with a name here in order to pass it to this event handler. So we are referencing it with inc, short form for increment. So we're adding an event listener, event of click. When you click on this button here, the counter will increment. So we are getting these elements here, the button element with an ID of increment. We're actually getting it and adding an event listener of click. Then when you click on it, inside the inner function, we've added another method that when you click on this button here, this document will get this ID of count. Then we insert the number inside of this div element. Initially, we placed in 0 here as the initial value of the div element. Then when you click this button, this event handler here will get access to this ID, access it, then place in the number. When you increment this number, 0 plus 10 will give you 10. So when you click on something, when you try to, oops, okay, let's go live again. Don't think the live server is so. Terminate this, go live. Okay, now we increase this, it's increasing by 10 because this is the value we specified. But if you say you want to increase by 1, you can say number plus plus, you want to increment by 1. Then when you click it, it will be increasing by 1, not by 10 or any other value. But in others, you want to expose this value to the user, that the user can pass in any value that he or she wants the number to be incremented by. Let's say you want the initial value. Let's initialize this to 0 so that even if the user doesn't pass in anything now, let's say this here is empty, but if you try to click it, you are still incrementing your number because it is initialized to 0 and the user don't need to pass anything here in order for the function to work. But he or she can also pass 20. Now this 20 will override this 0 and we set the initial value of this number to 20. Then if you click this button now, you are incrementing 20 by 1. That is 20 plus 1 because you are passing an initial value of 20 and you are still incrementing it here by 1. So if you click this button, it will increment by 1, then set the inner HTML of that div element to 21. Then if you click again, you have 22. The initial value was 20, increase by 1, you click, it will increase by 1 again, 23, you click, it will increase by 1 again, 24. But the user using it doesn't need to know everything here is hidden. The user only knows about the increment function, that he will call it, then pass in 20, then make use of it. He doesn't know any other implementation details. So this is possible with the use of closures because without closures, you cannot write any inner function that will be able to return the implementation logic to the outer function, then execute it for the user to get some result. So this is how closures are used in setting up event handlers and all of that. All of the implementation logic will not be exposed to the user, only the specific method you want the user to use in its code or something like that. Let's assume you are building a product for other developers to use and you want them to get access to a specific method. They will only get access to this increment and pass any value into it, then perform any task they want to perform, rather than going ever trying to understand the implementation logic. It also saves time for users of your product and all of that. So that's all about that. Do you understand about event handlers now with closures? Or I should go over it
Yes,
again?
yes, thank you, sir. But please, inside that code, there is something I have in mind then, but I don't think maybe it will work. So inside the event handler, when we pass the event name, then comma the handler function. So can we pass an anonymous function? Then inside the anonymous function, we just call the increment. Then we will get the return value and set it inside the
Okay,
the
you mean
HTML
this?
element. Yes.
You mean something like this?
Yes.
Yes, it will still work. But you have to be cautious of writing clean and maintainable code. You understand? That's why I extracted this function, brought it out here so that you can easily change this. You can change the name to any name you wish to result. If there's any conflict, you can change it to result and easily replace it here as result. Then passing any value here than changing complex things. So it's part of writing clean and maintainable code. So you have to make abstractions in order to keep note of your code. If you want to change anything, you easily change it without any problems.
Okay, thank you.
You're welcome. Any other questions? Everything I've been saying from beginning to the end is understandable, and we all understand the use of closures and how it can be applicable in solving different problems. Or is there any questions we need to answer? Any clarifications? Okay. I think we are left with about some minutes, and I think we had an awesome time explaining closures. And in review, all we were trying to talk about is trying to understand closure scope, lexical scope, the closure scope chain, how you can be able to follow up a complex closure scope chain and understand its functionalities and how it works, how the functions are being arranged, what the inner function does, what the outer function does, what the local scope is, what the enclosing scope, the block scope, function or module or global scope is, and the lexical scope. We try to understand the uses and importance of closures, the data privacy, function factories, callback functions, event handlers, and memorization. How we can hide our data and then expose some methods for the users to use without exposing our implementation details. In object-oriented programming, also known as encapsulation, when we get to object-oriented programming, we still make use of closures. There you understand deeply and how closures are being applied to solve problems, complex problems, not to pollute your working environment with JavaScript variables, because JavaScript lacks namespaces. So any variable you declare using var, the var keyword, it will pollute the working environment. So that's why in ES6, let and const were introduced to address this problem. So closures were also introduced to minimize the pollution of the working environment by not exposing your variables. Yeah, Joshua, you can go on. Yes, Joshua, you can go on with your question. Joshua, I thought you wanted asking a question. Okay, since Joshua is not saying anything, let's go ahead. At first, closures may seem confusing, but as we move on, we try to tackle and then solve other problems. We bring in closures and then apply them and then try to simplify those problems using just closures and sometimes objects. Yes, Joshua, you can go on.
Okay, just send the message to the chat. The chat section here. He said that he's having problem with his mic, and the question is that you should go over the memorization again.
Okay, memorization. You know, what you're trying to explain here is closures are not memorization. So I don't want to go deep into memorization, but memorization is simply a technique to like refactor your code and then optimize your code, like make your code optimal to work to like keep note of expensive functions and expensive calculations. You don't want to calculate every function over and over again if it involves complex calculations. You just want to go over, then bring in the previous calculation, then add it over to the subsequent calculation, and then get your result. So in overview, what this function is doing here is, you know, we all know about factorial now. This is the only simple example I can use to explain this. I don't want to go into Fibonacci series and all of the complex calculations and all of that. I just want to use a simple example so we can understand closures. We're not mainly talking about memorization here. We're talking about how we can apply closures to solve the problem of memorization. So in this case, we're calculating factorials. When you say 5, okay, let's start with a simple number like 4. 4 factorial here simply means this is equal to 4 times 3 times 2 times 1. This will give you 4 times 3 will give you 12. 12 times 2 will give you 24. 24 times 1 will give you 24. So if you bring in 4 here and you run your code, you get 24. So what this function is doing is, when you execute this function, there are 2 things involved. memoization and recursion. What recursion does is it will create a stack data structure. It will create a core stack for the recursion. So every function will be popped out. The first function, factorial of 4, will be popped out and added to the stack. Factorial of 3 will be added to the stack. Factorial of 2 will be added to the stack, and then factorial of 1, which will return 1, will be added to the stack. So after the program is done, it will rewind. The core stack will rewind, popping up out all of this. So what you will get here is, the stack data structure, it's last in, last out. So in this case, let's reverse the order. The last thing that we're doing it in reversed order here, n times factorial, and this we will have 4 times 3 times 2 times 1. So the last number that will be added to the stack is 1. So when you pop when the stack pops 1, it will return 1. The function will execute and return 1. Then multiply this, it will pop out the second function, which will return 2. Then 2 times 1 will also give you 2. Then it will pop out the third one, which is 3. Then 3 times 2 times 1 will give you 6, bringing 3 here. They will pop out the last function that was pushed into the stack, which is the 4, multiplied by 4. This will give you 4 times 3 times 2. But when popping out, notice what we get is 1 times 2. It will give you the result of 2. Then this will be memoized. It will be added to your cache. Then your cache now will have the value of 2. So in the subsequent calculation, when you try to bring out back 3, it will be 2 times 3, which will give you 6. Then the 6 will be pushed to your cache. Then the next calculation will bring 4, which will be 6 times 4. But without the cache now, every time you want to perform this calculation, it will go back and start with 1 times 2 times 3 times 4. Then 1 times 2. The subsequent calculation, which is 3, which will start with 1 times 2 times 3, will go back again. When we reach 4, it will start with 1 times 2 times 3 times, so which is time consuming. So when memoization comes in, where it comes in is after the first calculation, it will return 1, then multiply 1 by 2, store the 2 in the cache, multiply 3 by 2, store 6 in the cache. Then the last calculation 4, it will simply multiply it by 6, not wasting time or memory. That's where memoization comes in. Then that's recursion and memoization. Let's go over the function again. We earlier talked about this cache here. It's actually a private variable that can only be accessed in the lexical scope and the functional scope. That is a local scope. The outer function can access it as its local variable, and the inner function can also access it as its lexical scope variable. So we've declared it here. We don't want this variable here to be exposed. We only want to use it inside of this function to make use of it and memorize the whole factorial function so that the calculations will be simpler. So we first of all checked the base keys. In this case, recursion stops at 1. So when we get to 1, we want to return 1 instead of going further with the calculations. We don't want to go beyond 1, like 0 or -1 or negative values. We want to stop at 1. So we check if the first calculation is n in the cache. If 4 is inside the cache, then return 4 and then perform the subsequent calculation 3 times 4, then store it in the cache. But if it is not, add 4 to the cache. This is object. Let's say in dealing with objects, let me create another file and show you a simple test.js. If you create an empty object here, let's object equal to an empty object, and you say objects 1 is equal to 2, and you try to log this to the console. Fact is not, oh, sorry, test node, test dot, yeah. What you are getting here, you are getting, this is key and the value. The key here is 1 and the value is 2. So you gave it a key of 1, then you gave it a value of 2. So when you say you give it another key of let's say 5, and you give it a value of 10, if you log it to the console, console, you get that the object is having 2 keys and 2 values. The first key is having the value of 2. The second key, which is 5, is having the value of 10. So this is what we are simply doing. We're simply saying the key, the number that is returned, should serve as a key, and the number should also serve as a value. So if it's returned 2, the 2 is a key in string form, and the value is 5 in a numeric form. So when it goes on with the calculations, it will simply return the previous result and add it to the subsequent calculation, instead of going over and over again, wasting time and memory. That is simply the use of in order to understand this fully, I'll advise you go back and take a deep look into memorization and take a deep look into recursion. Then you fully understand what is going on inside this memorization function. At this point, I don't think we have much time. We're out of time. So Joshua, I'm sorry, maybe you drop your question on the channel. You go back and look at memorization and recursion, then you understand this better. I believe you've understood closures, but where your confusion is coming from is the memorization and recursion aspect. So thank you and you're welcome. Any other question? Any other question, please? Okay, so that will be all for today. And thank you all. Thank you for your time and everything. We'll meet again on Thursday, and I would like to hand over to Mr. Ike.
So where can we get the recorded video?
It's streamed on YouTube, and our coordinator, Mr. Ikes, will drop the YouTube link for you. So yes, so you can access it on YouTube. Yes.
Okay, thank you.
You're welcome. At this point, I will hand over to Mr. Ikes, and then that will be all for today. Thank you, and you're welcome once again.